Hi, my name is Ansi Broek. I am the head of mobile here at Regex Cybersecurity, and this is our mobile pen testing training series. In today's episode, we are going to be doing some static code analysis where we'll be searching for hard-coded secrets, vulnerable code, functionalities we can bypass, and exported content providers and intents. Let's see what we can find. Now, we have our Java decompiler, Regex, open. And we are now going to open our APK file that we've downloaded from Regex GitHub. So here on the left, we can see the package structure and everything. So here is our source code and our resources that the application uses. Most of these are built-in classes, so it's very likely that the developer did not write these himself. Java classes that you can utilize. And then we have our resources. These will be such as the icons and the colors and animations that is used within the application. Just by glancing over this, we can see that there isn't really any code obfuscation implemented because we can read all of these fairly easily. So CROM, Redshift, RS, Vapor training app. So it's safe to say that this is not obfuscated. .apk file is basically just a zip file that contains all of the application's packages, resources, and classes. You can even just rename the APK file and unzip it and look through these files. But Regex makes it way easier to just decompile the application. Here is all of the application's permission that it's utilizing. For example, the internet, read access storage. If it's using the internet, then it must be using some form of communication to the internet if it uses it. So we need to remember to look out for that later, but there's nothing too strange in the Android permissions. Sometimes in an application such as a camera application, it would be fairly strange if it has an internet permission. So things like that is things we have to look out for. Where the actual code that the developer has created for this application lies is in COM, and then the application name, so the package name, which in this case is redshift.rs_vapor training. Now this is all of the classes and packages that the application has. Okay, so this is all the default packages that's imported and being used, and this would be more what the developer has written itself. Okay, so here we have a add card class. We can see this is again the package name, and this package name will become important when we start using Frida and objection, so it's important to just take note of what our package name is. Okay, so here we have the imports. As we can see, sometimes Regex does break a little bit, so that's why it's kind of double import over here. But this is everything that's important. It's using on create, card add, and how it adds a card. Okay, so it uses some text fields and enters the values, and then it saves it in a database. As we can see here. Okay, and it uses an intent. Okay, so then it's just the intent. Okay, so it's important for us to later go look into the database when we do insecure data storage and logs, to go look into the databases if there's any clear text storage of the card information. Another interesting one could be the login. Now we can see again the package and all of the files it has imported. It's importing java.io.file, which means that it is potentially writing to disk, and we should look out for that when we do the insecure data storage. Here we can see on top there is 2 strings for an admin password and an admin user, so we can actually use these admin credentials to gain access to the application. So the admin username is admin and admin password is admin. So admin, we can access the application. That's great. Next we have here the onCreate. If we go down a bit, here it just adds the admin user into the database. Again, we should go look into the database later on. Here it adds new products, which is just the game. So game 1, very cool game, which is the game name, and this is where the person got the images from, the static images from. And then here's something very interesting. We have a credit card being added into the database. So this is obviously test data, so this is not a real credit card number, but it is being stored in clear text. We have the credit card number, the CVV number, the expiry, and then who the credit card is assigned from. So we have the admin credentials as well as his credit card. Now, credit card information is particularly bad when stored like this because of PCI compliances. So this is a fairly high risk to the company or to the application. And we should still look into the database how this is stored, but I am fairly certain that this is stored in clear text just like that. So very bad. This is a weakness. This is a high risk vulnerability actually. We also have a cookie being stored. Now, cookies are considered sensitive information, so the clear text storage of a cookie is also a vulnerability or a weakness that we can exploit. Now, let's go look into how the login works. We have if auth user is not null and if it's not rooted. So here we see a form of root detection, and we'll go look at that now. So if rooted, then make it toast. So toast is a pop-up notification on the phone. It says the phone is rooted, please uninstall the application, or then the user is not valid. So this is rooted. We can just double click it. We can actually also do find usage if you find a interesting code or functionality that you want to dig deeper into. In this case, we have R is root. Okay, so this is rooted, seems very interesting. So what we can do is we can find usage of. Then over here we can see this is where it's declared. It isn't the same class, but that find usage is a very useful functionality in the Regex GUI. So we see here the is rooted. So all it's doing is it's trying to find the SU binary. So find binary, and this is all the places that it is searching for. So what we potentially can do to bypass this is, well, firstly, we can just take out this is rooted, just take that part out. Or we can change this find binary to something that we know does not exist. So just change this to an incorrect or value, and then we could potentially bypass root detection over here by reverse engineering the application. So quite interesting. So just within the login class, we found the admin username and password, which is admin, clear state storage of a credit card, and then a cookie, as well as the root functionality that we can potentially bypass. Another thing we can do potentially is use a Regex Search and search for any 15-digit strings in the application code. Okay, so as you can see, by just going through the application code, we can find some pretty interesting information. So I would recommend you guys go through the code more in depth every time you have a application, just to understand what the application is doing and the structure thereof. For instance, we also now know that it is using a database, probably SQLite. So we know to go search in the database for any clear text information. So you can always keep looking through this code. We have found some pretty cool vulnerabilities that we can now use to access the application. But where there is some vulnerabilities, there's always more. So I do encourage you guys to go keep searching through the application code, see if there's anything more interesting. Maybe we can see if the application is vulnerable to SQL injection. And that was static code analysis. We found some pretty interesting things. In the next episode, we have dynamic code analysis. See you there.